Good day, children. Welcome to math class. What a wonderful day we have for you today. All right, we are talking about prime factorization. Today, we are going to learn how to break down some numbers. All right, so let's talk. I got a few vocabulary words for us today. One of them is prime number. We have a composite number. And then we have prime factorization. All right, prime number, composite number, and prime factorization. Remember to be writing these down in your notebook so you can look back at them and know what we are supposed to be doing. So, a prime number is a whole number greater than 1 that has exactly 2 factors. All right. So it's a whole number greater than 1 that has exactly 2 factors. And if you guys know about factors, you should have been talking about them last year. We remember that factors, they are like the smaller numbers that multiply together to get to a large number. Okay, so we'll talk more about factors in a little bit, but a prime number, an example of a prime number might be 11 because its factors are only 1 and 11. It can't be divided by anything. It can't be broken down into anything smaller. It's just going to be 1 and 11. All right, a composite number, so that's a prime number. A composite number is a whole number that has more than 2 factors. Whole number that has more than 2 factors. So an example of that might be 12 because its factors are 1, 2, 3, 4, 6, and 12. In this case, 3 and 4 multiply together, 2 and 6 multiply together, and 1 and 12 multiply together. All of those numbers multiply together to get to 12. So when we think about factors, we think about what are the smaller numbers that can multiply by something else to get to our original number. Okay, so that's what we deal with when we talk all about factors. All right, and then finally we have prime factorization. The prime factorization is a composite number written as a product of its prime numbers. So it's a composite number that's written as a product. What does product mean? This means multiplication. Multiplication. So it's a composite number that's written as a multiplication problem of all of its prime numbers. And this is where we're going to spend most of our time today, is dealing with prime factorization. And so how we deal with prime factorization is, one way we deal with that is we use what we call a factor tree. So if I say, hey, I want the prime factorization, I'm going to write that as PF. of 36. We use a factor tree to help us to understand the prime factorization of 36. So I'm going to write out 36 right here. And I'm going to say, all right, what are two numbers that multiply together to get to 36? We could say one example of that would be 4 and 9. All right, 4 times 9 equals 36. So we broke down 36 into two of its factors, 4 and 9. And we want to find out, we want to break these numbers all the way down until they're prime numbers. So is 4 a prime number, or can 4 be broken down even more? Well, 4 can be broken down even more. It breaks down to 2 times 2. And then we want to look and see those. Can those numbers be broken down anymore? Can 2 be broken down anymore, or is that a prime number? 2 is a prime number. So we're going to circle 2 to say we can't break that down anymore. We're going to circle that 2 to say we can't break that down anymore at all. Then we look at 9 and we say, all right, well, can we break 9 down? Or is 9 a prime number? This one is the one that tricks a lot of people. I've seen this one trick a lot of people. 9 can be broken down. 9 is not a prime number. It's an odd number, which we don't always love odd numbers, but 9 is not a prime number because 3 times 3 equals 9. But we do know that 3 is a prime number, and 3 is a prime number, so we'll circle both of those. And so now we have no more numbers we can break down. So the way we would write this out as an answer, so we would say the prime factorization of 36 is the product of its prime numbers. So we're going to multiply all the prime numbers. 2 times 2 times 3 times 3. And this would be our answer. 36 equals 2 times 2 times 3 times 3. Another way we can write 2 times 2 is 2 squared, and 3 times 3 is 3 squared. Do you remember when we did our exponents? So we could say 36 equals 2 squared times 3 squared. Either one of those will be okay, and I'll accept either one. I'm not looking for any one specific way that needs to work. All right, so that would be breaking down 36. Well, what if I said, okay, I actually now want a different one. I want to know, what is the prime factorization of 280? Prime factorization of 280. Well, I'm going to do the same thing I've done before. I'm going to break this down in using a factor tree. So I'm going to say, all right, here's 280. And what are two numbers that multiply together to equal 280? Well, I know anytime a number ends in a 0, it can always be divided by 10. So 10, and then the other rest of the value, this 28, is what's left over. So 280 breaks down into 10 times 28. And then I can look and say, well, 10 isn't prime because 10 breaks down into 2 times 5. And 2 is prime, and 5 is prime. So look at that. That whole branch now is taken care of. I can't go any farther down there. But I can break down 28. And 28 breaks down into 7 times 4. Now 7. Is 7 prime? Well, yes, it is. 7 is prime. We'll circle 7. Is 4 prime? No, 4 can still be broken down, and I'm going to continue to break this down. 4 breaks down into 2 times 2. 2 is prime. 2 is prime. I have no more numbers I can break down, so now I'm done here with my prime factorization of 2 times 2 times 2 times 5 times 7. 2 times 2 times 2 can also be written as 2 cubed times 5 times 7. And this works as an answer to my prime factorization. If you noticed here, and something I'm going to ask of you, is when we make this into the multiplication, right, our multiplication here, this needs to be in numerical order. So when we break down our numbers, I would like for them to be in numerical order, please. All right? So when we write out our math problem, please put it in order from smallest number up to our largest number. All right. What if I had something like, let's say I have 54. 54. And 54 can be broken down into 6 times 9. 54 can be broken down into 6 times 9. And 6 can be broken down into 2 times 3. Those are both prime. And 9 can be broken down into 3 times 3. Those are both prime. And so our answer ends up being 2 times 3 times 3 times 3, or 2 times 3 cubed. So we break down as much as we can. Once we get to our prime numbers, we circle those values, and we want to write out what this multiplication problem might look like. Now, let's try one like this. Let's say we have 40. Okay, and I'm going to say, all right, 40. I'm actually going to write it over here as well. 40 and 40. 40 can break down into 4 times 10. But 40 also could have broken down into 5 times 8. So which of these is going to be the right way to do this? Which of these will give me the right factorization for breaking down my numbers here? Let's check. 4 can break down here into 2 times 2, which are both prime. And 10 can break down into 2 times 5, which are also both prime. So that gives us a grand total of 2 times 2, times 2 times 2 times 5, or 2 cubed times 5. Okay, so that's what happens if I start with 4 and 10. But what if I start with 5 and 8? Well, 5 by itself is a prime number. Can't go any further than that. But 8 can turn into 2 times 4. 2 is a prime number. But 4 can break down into 2 times 2. And those both are prime as well, which gives us a total of 2 times 2 times 2 times 5, or 2 cubed times 5. And these two are the same. These are the same. So it doesn't matter. It doesn't actually matter which numbers you start with. You could start with 4 and 10. You could start with 5 and 8. You could have started with 2 and 20. Lots of things you could have started with to get these right numbers, and they will all get you the same thing, which is really great, really nice to know that we're not going to mess up because we chose the wrong first factor. Okay? All right. How do we think about prime factorization? What are we thinking? We feeling good? We feeling like it's something we're understanding a little bit, this factor tree situation? Hopefully, we'll work on it a little bit in class. So you guys can have a really good understanding of what's to come and how we can use this. Have a great rest of your day.